All right, let's continue the introduction to economics with the run through rational choice theory. My name is Tyler Moore from the University of Tulsa. So, we've talked about preferences and the fundamental axioms of rational choice. Now we're going to talk about utility functions. So, it's great to talk about preferences, but in order to actually do mathematical analysis and have a model that allows you to perform algebraic operations, we need to transform these sort of fuzzy notions of preferences into hard numbers. And so to do that, we need to measure utility. And I can say that, but what does that actually mean? Well, that's what we're going to find out today. Let's start by talking about what we don't mean. So we don't mean utility per se, according to Jeremy Bentham. So Jeremy Bentham was the founder of utilitarianism. He was a professor who helped found University College London in the 19th century. He, in fact, if you'd like to see him, if you're ever in London, I encourage you to drop by UCL. You can actually see him. There's a picture of him right there. He was definitely an eccentric guy, but one of the things he insisted upon was being preserved after he died, and then he was subsequently put on display. So he's still there if you'd like to see him. But what he said is that there's a fundamental axiom of utilitarianism, which is the greatest happiness of the greatest number that is the measure of right and wrong. So for him, a utility meant preferring pleasure over pain. We're going to get a little more specific than that with rational choice theory. And we define utility as a way of quantifying the preferences of consumers. So utility function U maps a set of outcomes onto real valued numbers. That is, you've got a mapping of the function from these outcomes we talked about earlier on mapping onto real numbers. And U is defined so that the utility of outcome 1 is greater than utility of outcome 2. That's equivalent to saying outcome 1 is preferred to outcome 2. So you have to have some way of consistently mapping your preferences onto these numbers so that the inequalities from the numbers hold in the same way that your preferences do. Agents then in turn act rationally by selecting the outcome that maximizes their utility. So for all the possible outcomes in the world, you pick the one that maximizes your utility. That's how you display that mathematically. So this doesn't say anything about what a utility function has to look like, and so you can construct many different ones, and you will typically do so by picking a custom function that maps to your sense of preferences of the various outcomes. So one logical choice would be this first example, where the utility of outcome 1 and 2 is just simply the linear combination of those two. So you have some constant u and v, which are basically a coefficient which would indicate how much you prefer one relative to the other. So u times O1 plus v times O2. So if you really liked outcome 1 more than outcome 2, but you still liked outcome 2, you'd have a larger value of u than for v. And this model is very useful whenever the outcomes you're considering are substitutes. So an example would be processor speed and RAM. So you want a fast computer. You can get that in part by both having a fast processor and having a large amount of RAM. And you're somewhat, you may have your own preference that for your application you prefer processor speed to RAM, but you'll take either one. You contrast that with the second utility function, which is the minimum of u times O1 and v times O2. So you would use a function like this whenever the outcomes are complements, which means that you have to have both in order to derive the utility. So an example complement from computing is operating system type and third-party software. So if you have the wrong software that works on a different OS, or let's say you're working at a company and you have 10 licenses of a third-party software, but only 5 licenses for the OS that it runs on. Well, your utility is going to be capped by the number of copies of the operating system that you have, because those extra 5 licenses that you have of the software don't do any good. So going back to our crypto example, we can take the preferences we talked about, where we're trading off between availability and confidentiality. We can take those preferences and map them to a utility function like this. So utility of AEI and CI is maybe going to be a constant U times AI plus the constant V times CI. And then so first question is why would this be a good choice? And the reason I would give is that the user values both availability and confidentiality. They are maybe substitutes to a certain extent, but you certainly value them both. So for simplicity, we're going to assign some actual numbers to these values for, say, for A plus, A minus, C plus, and C minus. So A plus is 1, A minus is -1, C is 1, and C minus is -1. Okay, so then it's important to note that utility is in the eye of the beholder, and that's where you can change the value for your constants U and V. So as a simplification, let's consider two scenarios. You have an intelligence agency who would tend to prefer confidentiality over availability. It's very important that they not be found out, and if they would rather just call an operation off rather than risk a breach of confidentiality. So for them, you might assign a value of U equals 1 and V equals 3 to show the relative preference for confidentiality. Whereas on the flip side, you have first responders, police and fire. They want to be able to communicate. It'd be great if it was confidential, but sometimes in the heat of the moment, availability matters more. So there U equals 3 and V equals 1. And once you have that, you can actually then plug it back into this utility function. So this U times AI plus V times CI. And so if you do that, you end up with something in the table that looks like this. So if they are both have high availability and confidentiality, then for both of them, their utility is high, it's 4. But in the case where availability is high and confidentiality is low, the first responder's utility is still positive, whereas it's negative for the intelligence agency. And I'll leave it as an exercise to you to compute this using that utility function for the other two scenarios with low availability, high confidentiality, and both low availability and confidentiality. And so I would say pause the video, write it out, and when you're done, hit play and you can see it. So assuming you're done, here's the results. Okay, so this concludes our discussion of utility.